Today's lesson, section 5.4a, we'll be talking about more trigonometric graphs. Okay, we're going to kind of attach period, amplitude, phase shifts, vertical shift, that kind of stuff to our tangent and cotangent graphs, so you can kind of see what those would look like. And then also we'll talk about a summary of sine, cosine, tangent, and cotangent with the important parts that you would need to be able to understand to like fully conceptualize what those functions will look like all the time. Okay? So for the graph of the following functions, I want to graph tangent of 2 times x minus pi over 4. So here I'm going to use the table version of this. Okay. So remember that I'm just going to focus on this first value, okay, of 0, and then from there I will worry about what the other values should be. Okay. So here, if I have pi over or x minus pi over 4, okay, remember that's telling you to move to the right. So to negate that, because you want to get 0, you want to add pi over 4. So 0 plus pi over 4 is pi over 4. Okay. Then from there, now you want to figure out what your period is now. Now remember, tangent and cotangent have a period of pi. So our k value in this case is 2. So now our period shrunk down to pi over 2. And then I want to break that into fourths, so that's like saying multiply by 1/4. So now my increments to make a period of full length of pi over 2, I need all those values to be pi over 8 away from each other. So the first value, remember, is still the same. It still starts at pi over 4. But now I'm going to add to that to find the next one. So instead of having this pi over 4, I'm going to add pi over 8 to this one that I started with, or I'm starting at. So pi over 4 is the same thing as 2 pi over 8, plus pi over 8 gives me 3 pi over 8. Okay? I do it again, add another pi over 8, that gives me 4 pi over 8, that's pi over 2. Okay? Then for pi over 2, I want to add a pi over 8, so that would give me 5 pi over 8. So remember, pi over 2 is the same thing as 4 pi over 8. Then 5 pi over 8 plus pi over 8 gives me 6 pi over 8, and that reduces to 3 pi over 4. So between pi over 4 to 3 pi over 4, that's a distance of pi over 2. So now I have my new x values. Okay, and so now I'm going to plug those into my tangent to find my values. So plugging in pi over 4 into there. So pi over 4 minus pi over 4 is 0. 0 times 2 is 0. So tangent of 0 should be 0. And then plugging in 3 pi over 8. 3 pi over 8 minus pi over 4. Remember, pi over 4 is the same thing as 2 pi over 8. So it gets me pi over 8. Then times 2 gets me pi over 4. So tangent of pi over 4 will get me 1. Now I know in the previous video we did like pi 6, pi thirds, and those give you those decimal values. And remember, I want you to graph the values that are nice and easy. And using those other pictures, those are kind of our parent functions. Now you kind of understand where those pictures and graphs should go. So where the line should approach for your asymptotes, those are the important parts. Okay, these points just get you the general area of what it should look like, and that's kind of what we're going for. Okay, we don't need super exact. We just want some points that are easy to graph so that we can kind of get the right picture for the most part. So now if I plug in pi over 2, pi over 2 minus pi over 4 is pi over 4 times 2 is pi over 2. So tangent of pi over 2 should be undefined. Okay? Then 5 pi over 8 minus pi over 4 is 3 pi over 8 times 2 gives me 3 pi over 4. So tangent of 3 pi over 4 is negative 1. And then when I plug in 3 pi over 4 minus pi over 4 is pi over 2. 2 times pi over 2 is pi. So tangent of pi is going to be 0. Okay, so now I got some nice numbers to plug in. So 0, so pi over 4 was at 0. 3 pi over 8 is 1, so that would be right here. Pi over 2 is undefined. Okay, then we said 5 pi over 8 is negative 1, and then 3 pi over 4 is 0 again. So you get this picture. Okay, that would be one complete period. And that's all you really need to graph, is one just complete period for that. Okay? So that's your picture. Now if you want to continue it, you can, and make complete ones, because that one kind of looks weird, but that's one complete period. So starting and stopping at the same spot. Alright? Now let's try it with the transformations. Now sometimes, and I think we talked about with this in the sine and cosine ones, if your value for your period, your k value, is inside, you have to factor it out before you can kind of figure out what your real phase shift is. So then if I take out the 3, then that's like dividing. Okay, so pi over 2 divided by 3 is the same thing as multiplying by 1/3. So that gives you pi over 6. Okay, so then for my transformations, this first transformation from the original cotangent of x should be x minus pi over 6. Then the next one should be 3 times x minus pi over 6. And then the last one, we're applying that amplitude of 2 on the outside. Okay? So start by graphing one period. So remember, we have asymptotes at 0, and let's say, because we want pi over 6, so let's make, just to be safe, let's go by pi over 12s, just in case. So that makes this pi over 4, pi over 3, so pi over 2. So that makes that pi. Okay. So we have another undefined line at cotangent from what we were surmising. Okay. And then for cotangent, remember pi over 4 was 1. So that would be right here. Okay. At pi over 2, it's 0. At 3 pi over 4, it's negative 1. Okay. So then 1. So one period of cotangent would look like that. Okay. So then the next one, now if we're using a phase shift of pi over 6, remember that's saying to the right pi over 6. So move all your values to the right pi over 6. So that means my asymptote would move to pi over 6. This one would move over a pi over 6. Pi over 2 would now be at 2 pi over 3. And then our 3 pi over 4 value will be at 5 pi over, or actually 11 pi over 12. And then the one at pi should be at 7 pi over 6. So now your graph looks like that. Okay? And the next one is this period. Remember your period is originally pi. So now dividing by a k value is pi over 3. Huh? So now you want your increments, if you're going to do division of 4, is going to be pi over 12. Okay? So starting with that first value, which is the undefined line, okay? This is where it shrinks. So this green one now moves a pi over 12 away from your original one, so it goes back to where it was before. Then another pi over 12 over would be right here, and our next value is 0. And then another pi over 12 would be right here, and that value would be -1. And so then now we have an asymptote at pi over 2. So there's one period, shrunk. Because we said it's a distance of pi over 3, from pi over 6 to pi over 2, that's actually a distance of pi over 3. So that's one period. Okay, so that's correct. Now we go to the last one, is our amplitude of 2. So then all our values get stretched vertically. Now that doesn't change our asymptotes at all. Okay, undefined is undefined no matter what you do. But at 1 that becomes 2, and at -1 it becomes -2. But 0 is still 0. So then the orange should be our final graph. Okay, and that would be my graph for the function of y equals 2 cotangent of 3x minus pi over 2 that we started originally with. Okay? Now here's for a summary. So I have my 4 trig functions that we've already talked about and graphed. We kind of talked about domain and range for them. So let's write them out. So for sine and cosine, it's negative infinity to infinity. And then our range values for sine and for cosine are restricted to just values from in between -1, or from -1 to 1. Okay? For tangent, it's all reals, so infinity or negative infinity to infinity, except because of those asymptotes, they kind of make a barrier, so you can't get all the x values that you want. So we want to exclude where those the asymptotes happen. So the first one kind of is at pi over 2, but they happen every pi. So if we say plus pi k, we can cover all the asymptotes without having to write them all physically. Okay, k is going to be some integer that you can plug in, and then you could go straight to an asymptote in that case. Okay, cotangent's kind of the same way, except you start at 0. That's the first one. So we could say 0 plus pi k, or, for easy sake, that's the same thing as just saying pi times k. So k is any integer that you could plug in and send you straight to an asymptote for cotangent. Okay? Now the ranges for those are all reals. You can get whatever value you want for either one. So we put negative infinity to infinity there. The zeros happen at specific values. So sine happens every pi k. Okay, so kind of like starting at 0. That's the first y value that you get 0. And then if you go to pi, that's 0. And then 2 pi, it's 0. And so on and so forth. Cosine's the same, except you would be at pi over 2 plus every pi k. So at pi over 2, 3 pi over 2, 5 pi over 2, so on and so forth. You always get 0 there. Okay? Tangent and cotangent. Now tangent is, remember, because you want the sine value divided by the cosine values, tangent and sine are actually have the same zeros at the same points every time. So we can say every pi k. Cotangent and cosine, because cosine is in the numerator of cotangent when you divide, to find your ratios, they share that zero ability. So it would have the same thing as cosine. Now asymptotes, sine and cosine never create any asymptotes on your graph. Tangent and cotangent, obviously they do, but that's where those exceptions were at. So for tangent, remember that was at pi over 2 plus pi k. So that's where it blocks the domain from being all reals. And then cotangent is the same way, but it's at pi k. And then the period, we've already kind of talked about this. Tangent, or sine and cosine have a period of 2 pi. Tangent and cotangent have a period of pi. And then the nice thing is that all of them share the amplitude of absolute value of A. Alright? So that's kind of a summary. Once we come back to trig graphs, we're going to talk about secant and cosecant, and then we'll add to the summary that we've already started here, and we'll talk about what those ones are. Okay? Have fun.